Hello, everybody. We are going to start very soon. Let's wait for half a minute until more people enter the webinar. By the way, let us know where you are joining us from. We have registrations for quite a few different countries.
So should we start? I think everyone who wanted to join us already here.
Yeah. Okay. So let's start. Hello, everyone, and welcome. I'm Igor Omelianchuk, and this is Andrew Lychuk, and we are with Corsac Technologies, a software modernization company, and we're excited to share with you one of the most impactful AI projects that we worked on here at Corsac Technologies. But first, we'll start with short introduction. I work in tech since 2012, and what I've been doing, I've been helping companies with business operations to optimize revenue and delivery during modernization and development projects. I also helped to launch several different projects for enterprise software modernization, and generally, I've been helping companies create and establish sustainable development and modernization processes to make sure that they retain competitive advantage. Andrew, please introduce yourself.
Thank you. So I'm Andrew Lychuk. I have more than 20 years experience in tech. And my main role is and was actually helping companies to build the software product from the scratch throughout the whole software development life cycle. And I've built quite a few of them, like it's indicated here, more than 30 projects, and I built teams, more than 100 team members in a team.
Okay, great. And now let's get to the overview of what we're going to speak about. Today, we're going to take you behind the scenes for Bacterial. It's a product that we built for the client, an AI-powered system that completely reimagines how we test bacteria and how we evaluate antibiotic effectiveness. So this is how the website of our client looks. I will give a short overview of the webinar. So first we'll tackle the problem that they were planning to solve. We'll go through the challenges, and most of this project was going through the challenges. Then we'll get to how we actually built the model, what were the results, and what we as a software company and them as a product solution provider, essentially, what they learned from this project and what's the future of the project and how it can be implemented in real world. So what is Bacterial? Bacterial is an AI-powered system that tries to reimagine how we test bacteria and how we can prescribe treatment faster. This project is a great example of how a custom domain-specific AI approach can solve real-world healthcare problems, not in theory, but in practice. So let's get to the problem definition. Traditional antibiotic susceptibility testing is slow. The process of figuring out which antibiotic will work against a particular infection usually takes 2 to 3 days. So basically 2 to 3 days you need to grow bacterial cultures and analyze the results. That's very long when we deal with serious infections, and faster diagnosis in this situation would give an apparent and clear value. So our client, Bacterial, wanted to design a product to solve this problem. The goal was ambitious: to reduce the time needed to evaluate antibiotic effectiveness from days to just a few hours, and not to sacrifice accuracy, apparently. We had the capacity to help them since we focus on custom AI development and modernization, and we could create a custom system backed by scientific methods. And we were not limited by any specific solution because again, we were tackling this problem from a custom perspective, and we were not limited by any specific solution for that. Basically, we needed to modernize the process of evaluating antibiotic effectiveness in close collaboration with medical experts. And again, on our part, we were fully responsible for the implementation part. We did not start from scratch. Apparently, we worked with existing lab equipment, and we needed to work with legacy data formats and workflows that microbiologists already trusted. When this is specifics of implementing any solutions in healthcare, you never have blank page. You always need to work with something that's already there. You always need to follow certain procedures, certain operations, certain requirements, which can be legislative requirements, it can be processual requirements, so on and so forth. So again, our task was to upgrade the process, not to reinvent it. By the way, this is usually what modernization is. It's keeping what works and improving what slows you down. It's usually not reinventing everything from scratch. So before we get to the actual challenges that we faced, I wanted to point out your attention that if you'd like to book a consultation to discuss your problem, please click the button on the bottom right. So now I will give the word to Andrew, since he was more involved in the project than me. Andrew, please explain the challenges that we faced during the project implementation.
Thank you, Igor. So now it's a time for boring technical information. So let's go through the main challenges one by one. The first big challenge we faced was microscope automation. Unlike a regular camera, a microscope doesn't just snap a photo. Every sample has different depths and layers, so the system needs to precisely focus for each one. Our microscope produced only one image every 10 seconds, and the samples were cooled to keep the bacteria from moving. So we had a very narrow window to capture good data. The samples started to heat from the light we needed to take photos. So we needed to act fast, otherwise our result could be compromised. To solve this, we designed an algorithm that captures several images at different focal distances, typically 4 or 5, and then uses extrapolation to determine the area of the best sharpness. This allowed us to obtain high-quality images suitable for further analysis. It's a simple idea, but it dramatically improved image quality and consistency, which is essential for an AI analysis that follows. Now we could make the images that we needed for analysis and model training. Igor, could you please move the...
Yes.
Thank you. Okay, so let's continue. The next hurdle was data, or rather the lack of data. We could make an image, but now we needed a lot of them, and we needed to label the data. So actually to label the data on each of the image. AI system needs lots of high quality labeled images to learn from. These images must be in a certain format and must be appropriately marked and labeled. That usually takes lots of time and effort. But in our case, the microscope was still in experimental use, and we had very few samples available that time. Every attempt to detect bacteria using classical computer vision methods didn't work well. And we quickly realized that we needed to manually label a significant amount of data, especially focusing on bacteria exposed to antibiotics, which often had irregular or damaged shapes. This was very time-consuming. A single image could contain thousands of bacteria, but it was a critical step. It's a good example of something we emphasize in every AI project. AI isn't just about algorithm, it's about thoughtful data preparation. Oh, by the way, Igor, do you remember the project when we had a client who had to fall on a mat and we were filming it?
Yes, we had a pretty fun project a few years ago when we needed to create an algorithm basically based on videos for fall detection. The idea was to help the elderly facilities to track their patients if they fall somewhere in the corridor. And what we had to do to create the foundation of the algorithm is to get enough data to train the model, define if the person fell. We first tried to gather this data in the internet from free sources, but quickly figured out that it was, first of all, it was a pretty tedious process. Second, the data was so varied that making it more or less uniform was almost impossible, because those were literally random videos with random quality of random people, and it was difficult to work with. So what we did is, by the way, the client wanted to participate in the process. So the client actually decided to film how he was falling. So he put on the motorcycle protection. He had the mat, several cameras, and he was falling on the mat, and we were filming it from several angles. And he fell dozens, maybe hundreds of times, and we filmed it from various angles. And that data actually helped us create the foundation. So we took all those videos, we labeled all of them, and that actually helped us create the foundation of algorithm. And that project is also an example of how you can work in, how to say, more or less home conditions. So you don't need very expensive hardware. You don't really need a specific studio. You don't need lots of people involved to create the foundation for your project. Yeah, Andrew, please
Yeah, that
continue.
was fun experience, and we were lucky enough that our client was a good actor because falling intentional and unintentional is really different stuff, and the client actually managed to fall in the way like elderly people actually they fall.
Yeah, and no
Mm.
client was hurt in the process of filming that video, by the way.
Yeah. Okay, thank you. Thank you for sharing us the next information. So let's continue. Once we had enough labeled data, the next step was teaching the system to recognize different states of bacteria. Our model wasn't just looking for bacteria or no bacteria. It needed to understand more subtle biological results, such as healthy, metabolically active bacteria, damaged bacteria that are still alive but structurally altered, fully destroyed bacteria, and bacterial clusters, which are groups that can indicate antibiotics resistance. Uh, this is where domain experts actually matters. Working closely with microbiologists, we structured the system so it could interpret what these changes mean in a clinical context, not just identify shapes. We structured the dataset so the model could distinguish not only individual bacteria, but also their formation, because bacterial clusters often correlate with antibiotic resistance. And this is something we need to take into account. Yeah, thank you Igor, for showing us the next slide. So, uh, with the bacteria now correctly identified, we focused on the ultimate goal, determining whether an antibiotic is working. Our approach analyzed each sample across several patterns, such as bacterial shape, size, group patterns, and light characteristics, and then classified the outcome into three categories, which are antibiotics effective, antibiotic is not effective, and inconclusive. Each bacterial image was analyzed for parameters such as length, width, aspect ratio, clustered behaviors, and light intensity. These metrics allowed the model to detect antibiotic effect with high confidence, even from relatively small data set. Oh, you're showing us some cats. Yes. So this classification is powerful because it gives doctors actionable information fast. Instead of waiting days, it can start the most effective treatment within 3 to 5 hours.
Yeah, I will explain why I'm actually showing cats instead of bacteria. Uh, as it often happens on such scientifically heavy projects, we deal with proprietary information, so I cannot actually show you many of the images from the research. but the algorithms that we use is completely applicable to pretty much any types of images. So in this case, we are just showing how it can be used to identify three different cats on the image. Same way it can be used for identifying different types of bacteria in the image, different types of some kind of hardware equipment, different types of pretty much anything you can imagine if you can structure that data.
Yeah, actually, for computer vision, it doesn't really matter if these are cats, bacteria, or anything else. Yeah. Okay, Igor, could you please show us the next slide? Thank you very much. Okay. So the training process. So the model was trained in two steps. First, using optimizer until the learning plateaued. Then switching to another optimizer with a different learning rate to continue improvement. These two-phase training approaches help the model achieve consistent, stable result. Thank you. So, and the result actually were better than we expected. Our solution achieved over 95% accuracy in detecting bacterial responses for certain strains, outperforming many existing approaches. The entire process from preparing bacteria samples to generating AI-based analysis took only 3 to 5 hours, compared to traditional methods that require several days. This time reduction allows medical professionals to identify effective antibiotics much faster and start proper treatment almost immediately. Of course, in healthcare, accuracy isn't enough. We also need to prove that the results are scientifically valid. This project combined microscopy automation, computer vision, and AI-driven classification to create a scientific tool capable of evaluating antibiotic effectiveness in near real time. We also developed a mathematical framework to assess whether the classifier's predictions were statistically reliable rather than random, ensuring real scientific validity. It was another achievement which could be reused on a similar projects. So, in summary, Bug2Byte demonstrates how AI can speed up microbiological research and antibiotic testing. The system automates image capture, analyzes bacterial morphology, and determines antibiotic effectiveness with impressive accuracy and efficiency. As future work, we plan to refine the neural architecture, expand dataset, and improve integration with clinical environments, making this technology an essential part of next generation diagnostic workflows. What also important about Bug2Byte is that it's not just a story about machine learning. It's a story about how to approach complex healthcare challenges with AI.
Thank you, Andrei. Now I will get to the lessons that we learned from this project and the general conclusions. So here's what we learned. The first is focus on the problem. Any company building a software product, any company introducing AI, any company doing modernization, first needs to focus on the problem, not on the technology. We build algorithms only after deeply understanding the workflow and pain points, and we tried different approaches and technologies for that, and many of them didn't work at the beginning. And a common mistake, like generally a common mistake that modern AI startups often do, is they focus on the technology. They had some idea of a model, they had some idea of a product, and they focused on what's already there and what they can do from tech standpoint, not thinking what they have to do from problem solving standpoint. They literally forget that the technology is just a tool, and without the actual problem to solve, it's mostly useless. So on Bug2Byte, we tried to make sure that our technological approach suited the problem being solved, and basically did give the results. The next point would be collaborating with experts. Collaboration with domain experts is, at such projects, it's the most important thing, basically. Domain knowledge is essential. It always goes first. The tech never goes first in this situation. Close collaboration with medical professionals helped us understand some things which we would never figure out only from technical perspective. And what was also very valuable is that medical professionals managed to see through the software development process, through the implementation process, and they could understand how tech can be used to solve the problem that they deal with, how it's used to create the actual solution. And we helped each other basically, and it seemed to work out well. The next point.
Can I add here? Actually, the customer Back2Byte was sent me that you should have a problem owner in your team, so which is domain experts essentially.
Yeah. And by the way, as the result of the project, I know for sure that they've already written 2 scientific articles, and I believe they're writing the 3rd scientific article right now based on the results of this project. So the third point, let's get back to the presentation. The third point was essentially embracing messy real-world data. Our solution was successful not because we had perfect data, but because we designed it for imperfect real-world conditions. This is an argument in support of adjusting any technology you have to solve real-life problems and in real-life conditions. If your tech does not work with the data that will be received in the field, the tech is useless. And the problem, if your tech doesn't work, the problem is not the data, the problem is the tech. And the final point would be prioritizing real impact. Prioritize not just real impact, prioritizing real impact and understanding the focus of the entire project. Again, this is something that's often lost on software development projects. Every design decision that we had on Back2Byte, we made with one goal in mind: get reliable results faster so that patients can be treated sooner. This vector helped us prioritize our efforts and resources and be more efficient from budget perspective, be more efficient from time perspective, be more efficient from defining what we need to work on. It helped us to save a lot of time and avoid endless rework in the areas where we needed to rework things. If any of the people who are listening to us now know something about software development, rework is one of the most difficult problems to solve during any project. You always have rework. And now let's get to the next point, is looking ahead, future of AI in microbiology and what will be next in this project. So in the future, we plan to refine our models. We will expand the data. We will integrate this technology directly into clinical environments. There's still lots of work to do there. The overall approach can be applied not only to healthcare, it can be applied to pretty much any industry which needs image recognition, since any type of video or image can be analyzed in a similar manner. For us, the project became a case study in modernization, not only in AI implementation, since we learned how to take a process that's been the same for decades, and that was, how to say that properly, that was very usual for everybody and nobody really tried to challenge it, and how to take such a project and process and turn it into a digital data-driven system without breaking what's already there. We believe that systems like Back2Byte will become a standard part of next generation diagnostic workflows and software. And they will help doctors to make better decisions, make the decisions faster, and save more lives. It's an example of exploring how AI can modernize medical operations and ultimately improve patient outcomes. And here we're basically coming to the completion of our main part. Now let's get to the questions. We do have questions in the chat, I see. So I will go briefly through them and pick some of them that I think we can answer. Okay, so the first question would be, you mentioned limited data was a big issue. How do you usually overcome that in other projects? Andrew, I believe.
Igor, yeah, let me answer that.
Yeah,
yes, for sure, data scarcity is one of the most common obstacles in AI. in AI development, especially in specialized fields like healthcare, manufacturing, or defense. At Corsac, we use mix of strategic data engineering and creative augmentation. Um, so we collaborate with domain experts to extract maximum insights from a limited small data set. We use controlled data augmentation like rotation, adding some noise, small distortions to synthetically expand the data sets while preserving clinical meaning. And when possible, we build hybrid models that combine rule-based logic with machine learning, so they remain reliable even with limited data. In short, we design AI that can work in imperfect conditions because in real life, data is rarely perfect. But sometimes we just need to get more data and manually mark it. That's life. Yeah,
Yeah, and
I
that
think that's
was
it.
yeah, that's what happened at Bactibyte, and that's what happened, by the way, at that project where we needed to do fault detection. In some cases, you just mark manually.
Yeah.
Okay, what's the next question? The next question would be: can the same approach be applied to industries outside healthcare? Andrew?
Let me answer as well. Absolutely. While Back to Byte was built for microbiology, the underlying approach, like automation, visual analysis, like identifying patterns and classifying results from image or video, can be applied anywhere visual data is critical. For example, in radiology, like for detecting subtle anomalies in X-rays or CT scans in manufacturing, like for spotting microscopic defects on production lines or so. In agriculture, like monitoring cell or crop health from camera feeds. So what we delivered with Back to Byte is basically a blueprint for applying AI to any process that involves seeing, measuring, and deciding faster. It's not just one tool.
Yeah. Okay, thank you. The next would be: how did you ensure the system's reliability and safety for use in clinical environments?
Oh, that's a good question. Let me answer this one as well. So this is for sure it's a crucial point. Healthcare solution must not only be accurate but scientifically valid and transparent to ensure reliability. What we did, we work closely with microbiologists to verify the biological meaning of every AI output. As I mentioned, we developed a mathematical validation framework that tests whether AI predictions are learned patterns, not just some random coincidences. And we made the system interpretable. It doesn't just say antibiotic works. It shows why, based on measurable bacterial changes. So medical professional can verify it.
Okay, thank you. And the next question probably would be the last one. What would you recommend to organizations that want to modernize their processes with AI but don't know where to start? And I will take this one, so I could answer at least one. The standard but not obvious answer is: start with the problem, not the technology. That might sound simple, but that's the most important lessons that we learn from Back to Byte and other projects. Many teams begin with the model, with a certain technology, with a certain product, with a certain solution, maybe with something they heard about, a certain framework in mind, and they try to fit that technology to whatever problem they're trying to solve. And inevitably, they end up changing the problem. That always happens when you already have a ready technology. But in reality, a modernization project, it always starts by mapping out the workflow, mapping out the problem. So identifying what slows you down, where data lives, what decisions could be improved by automation. Sometimes you will come to the conclusion that not everything can be improved from technical perspective. Sometimes it's just a problem on operational level. For example, our goal when working with the client is usually to guide this discovery process, because this discovery process at the beginning, not the technical planning. First is the discovery. We help them evaluate where AI, or maybe not AI, maybe other technology, can realistically deliver value. We can design some pilot projects. We build modular solutions that we can later scale. But again, initially, it's the discovery process. It's the problem. It's the workflow that can be optimized. It's never the technology at the beginning. So, for example, if you don't have a clear technical vision yet, but you do understand the problem that you want to solve, that's completely okay. We can help you with that. Our goal is to make the process practical, measurable, and aligned with your organization goals, whatever technology you want to implement. And I believe, that was the last question. And we will reply other questions in our LinkedIn. We will save all of them, so don't worry if you asked the question and we didn't reply it. Please subscribe to our LinkedIn, and you'll see the answers there. Hopefully, very soon we'll do our best. So please follow us there. If you would like to book a consultation, you would like to discuss the problem that you have and get some technical insight on how it can be solved, please click on the link on the bottom right, and we'll be happy to talk to you. And we'll probably wrap up our webinar for now. To reiterate, at Corsac Technologies, our mission is to partner with organizations in healthcare and beyond to modernize software and processes, and that way help them maintain competitive advantage and reach their goals. I hope this session gave you a deeper understanding of how AI can be implemented with this real life case, and specifically how it can be implemented in healthcare. And of course, if you'd like to explore how we can help you with modernization of your processes, we'd love to continue the conversation, and we would be very happy to see you on further webinars that we'll be having at least monthly. So thanks everybody, and have a great day.